When I left home today, I was maybe wondering because the weather was so dramatic today, and I thought there might not be enough people coming, but good to see all of you tonight. Before I start, I just want to double check I'm in the right room and they'll set up expectation. Like, how many of you have heard of RAG? Oh, good, nice. So we're in the right place. So yeah, by the way, my name is Joshua, and I worked for Neo4j before. Then I joined OntoText, which is an RDF database. As you might already know, Neo4j is a labeled property graph, and OntoText is an RDF graph. Well, it doesn't matter; it's not just graph. And then now I'm running my own kind of AI startup, doing something very similar to GraphRAG. So I'd like to share with you a project I did early this year, which was actually kind of going through the research papers done in 2024, last year, about RAG. And trying to understand, like in the research space, in the enterprise space, does RAG actually work? And if it doesn't, what's missing? So going back to 2020, right? That was the first time the concept of RAG was introduced by Meta, the retrieval augmented generation, right? The idea is pretty simple, like a large language model or language model can do certain things like summarizing the content, generating the sentences, but you can also combine it with a local knowledge base. It will provide more factual or more grounded knowledge or generations, right? That was the concept. There has a lot of promises at the time, and since 2022, when GPT, it was exactly 3 years ago, when ChatGPT 3, wasn't it? GPT 3 was released. All of a sudden, everybody was talking about large language model, GPT, blah, 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 right? And that also made RAG a very, very popular application since then. So I did research, right? Back in 2020, but by the way, all the numbers came from ARXIV. If you follow the research papers, you probably know the website. So in 2020, there's roughly merely 2 papers mentioning about RAG, retrieval augmented generation. In a year later, it was about 7. 2022 was about 20. And all of a sudden, in 2023, 2024, it jumped to 1,200 and more papers talking about RAG. I did check how many papers are talking about RAG this year till October. I think the total number was about like 4,900, 700 something, right? Regardless, right? It tells us a big story, right? RAG is something very, very real and more appealing to both enterprises as well as research institutes. And driven by the proliferation of large language models, as well as the enterprise interest, right? Are we able to use RAG, use a large language model, generative AI to, for example, to make the data analysis more accessible to normal people, or make unstructured document more, value all of the unstructured documents? Somebody just mentioned, right, whether the knowledge can be inferred or can be generated by itself, and new knowledge can be recognized, so on and so forth. Right, that's how we see this big trend. Then there were getting to the fundamentals, right? Why we actually need RAG in the first place? Because the large language models have their own limitations, right? First of all, we all heard of the word hallucination, right? Making up things from nowhere. So the key promises of RAG were to reduce hallucination by grounding outputs in verifiable data and improving the factuality. So if we provided the fact, we provided the actual data, will a large language model be able to generate the outcomes based on the facts? And then number 3, to enable explainability, how and why large language models generate such an outcome based on the facts, right? We're trying to figure out, is there any traceability or explainability of how those models work? That's the 3 big promises. So promise 1, let's have a quick look. Reduce hallucination. So based on the research papers, it does work, right? Like roughly 70% of hallucination were reduced, according to one of the research papers. And once we provide a structured facts or context from the knowledge base, from our enterprise data sources to the models, there are also benchmarks published to enable targeted improvements. And it's proven with better grounding, the results can be verified. But on the other side, there are still gaps, right? Not entirely hallucination-free. You might heard of the words like the loss in the middle. So when the context is pretty big, large language model might forget what's mentioned at the early stage, in the beginning of the context, right? And sometimes when there are conflicting facts within the context, large language models might not just use the later one, rather than telling there are some conflicts in your data. And also the quality largely depends on the retrieval relevance. So the retrieval augmented generations, whatever we retrieved actually can largely drive the outcome of the generation. Then integration discrepancies still occur. We still see some strange behaviors of the large language model. The promise to improve factuality, there are also a significant improvement. The frameworks is both semantically and also based on the data itself. And also the large language model can better handle the time-sensitive queries. Like how expensive, how long, like for example, OpenAI trained its model, right? It took like billions of dollars, it took like a month to go. So the large language model themselves can never have the most up-to-date data in it. Well, they can produce much more up-to-date results today, but through other mechanisms. And also domain-specific, like ChatGPT, they have the knowledge of the word, but not the domain-specific knowledge. So the gaps are dependent on the source quality. Again, data quality is the key, right? Outdated sources still affect the accuracy. And also the alignment challenges remain. For example, if you ask a large language model, please provide somebody's text file number, it might just give to you. But it's actually against the privacy policy, right? But at the moment, this is still another gap. Explainability, right? So the idea is for RAG is to provide the source of truth and provide relevant data to the specific question, so large language models can generate answers from them. So we kind of have some kind of traceability, right? By giving this context, this data about your customer, the large language model produce this outcome. But how exactly inside of the large language model, how they actually think and integrate the knowledge from different sources, how to solve the conflicts we still don't quite understand, to be honest. It still looks like a black box. That brings a lot of challenges to a RAG project, right? If something goes wrong, what are we gonna do? I don't know whether you have some experiences with RAG. Personally, I've done 3 for oil and gas in the oil and gas industry, for telco, and for manufacturing. It's like the weather today, right? In the morning it's so horrible, right? There's massive data, massive cloud, massive rainfall. And at lunchtime, the sun came out. Oh, so bright. We have large language model today. We can do many more things than we can even imagine before. Then the project kicked off. Then the people start confused. People have different opinions. And what are we going to do? And the initial demo of RAG is always very, very quick. You can do a RAG demo in almost like 5 minutes, believe it or not, if you have done that before. Then the weather changed again. In the late afternoon, the storm came again, right? Heavy rain, that's why I was late. And now it looks bright again. So the RAG project is very much like this, the weather of Melbourne. If we do this in Sydney, you'll probably see something different. But yeah, it's exactly the experience. Like the customer expectation or user experiences compared to the initial excitement from the demo is very far, to be honest. And then the challenge was, if something goes wrong with the generation process, with the model itself, what are we gonna do, right? So the researchers try to solve the problem. If you see the areas of research those papers cover, if you see most of them, more than 20% focus on retrieval approach. The idea was, if we can retrieve the most relevant content to the model, ideally, it should produce much better results. That's actually pretty reasonable. Then the multimodal system, like other than text, can we also do images? Can we also do audios, right? Those are other type of data, and even graph. And the generation optimization, benchmarking, end-to-end, and applications, right? These are the most, like, accounted roughly more than 60% of the research is done, which is quite reasonable, I would say. But if you also noticed something very popular this year, didn't have that much of the attention last year, which was agentic. Now we all talk about agents, this, agent that, right? Agentic RAG, agentic LLM, whatever. I think when people start to realize, we can't just use the old programming way to predefine the structure, the rules, how a system should work. If we can use agents to do this work for us, right, that should be able to improve the overall performance of RAG. Right? So we see the trend, right? Over time, based on the time when those papers were published, right? But are we there yet, right? Again, I mentioned in the beginning there are about 1,200 more plus papers talking about RAG, and that's roughly count. I just can't do that much. So, but it's still low, like more than 270 RAG solutions being published. There are different variants focusing on different areas. And also the challenges still remain in the like a multi-hop questions, like a knowledge graph Q&A, like a most interesting one. One of them is the multi-hop, for example, who worked at the University of Melbourne won the Nobel Prize, and who else won the Nobel Prize for physics, for example? Who else won the Nobel Prize for chemistry, for example? So you need to figure out who worked here, and what is nationality, which university person worked for, and which Nobel Prize. That's the first hop. Then you need to figure out anybody else who won the Nobel Prize of chemistry, the second hop, and see whether there is a connection. Do both people living in Melbourne? Something like that. That's multi-hop questions. You can think about for the chain of the thought, the chain of the question can be very, very long, right? For those type of questions, right, still we need to, there's still a lot of challenges try to make those work in that very relatively complicated scenario. And again, also there's no standard metric. If you really want to test whether the RAG solution works or not, you need to figure out what data set you should use, what's the test cases you should design, and what are the metrics, right? Not like some generally approved or endorsed matrix, like a large language model has the MMLU, and also specifically the domain challenge. For a RAG solution to work for a specific domain, right? Still a lot of challenges, a lot of questions. So that's why I see from this year, right, we see two major directions for RAG. One is the knowledge graph, more use of knowledge graph. The second is agentic RAG. So I will focus on the knowledge graph today because this is the graph version of the event. So the idea is for complex, you can think about the multi-hop question itself. If we can store those knowledge into a graph. It becomes very simple operation of a traversal from one person to another person to Nobel Prize to the location where the person lived in or to which university. It's just a matter of doing graph traversal, which convert a very complex question into something we could easily program, right? The graph traversal problem. And on the other side, if the contents of the documents, we can harvest the structure or topology from those documents, unstructured data, which can also can also make the search more relevant to the question, right? And so on and so forth. And also the semantic web ontology itself is a graph, right? That's why knowledge graph actually have a lot of use in the RAG solution. So that's the paper published early this year about the GraphRAG, the whole landscape of GraphRAG. So, by the way, the answer questions from knowledge graph, from knowledge base, is not something new. It has been there for many years. It was used to be called KGQA, knowledge graph Q&A. But with a lot of GenAI, we see new trends coming. Like, for example, you heard of the GraphRAG. That is a solution focusing on something very similar to that type of index, right? Based on the content, based on the semantic of the content, try to build a second index to improve. So it's focusing on the retrieval, retrieval. But also we have seen other ways of doing the GraphRAG, the knowledge integration, how we can harvest the entities, relationships from all kinds of data sources, do entity recognition or extraction, relationship extraction, link prediction, right, to generate new relationships between entities, and to do entity linking, right. For example, as I mentioned previously in the session mentioned about Wikipedia. The Wikipedia has a large, massive knowledge base about all of the entities. And every entity has a unique ID, so they can be within different systems. They understand we're talking about the same thing. We refer to the same thing, right? That's that. And there's also all knowledge organizations storing the knowledge as a graph, right? So we can have a very flexible schema. Well, in fact, not like graph database like Neo4j does not, strictly speaking, does not have a schema. So if you talk about a relational database, what are we gonna do? You're data engineers. We do we do logical model design. Then we do physical modeling. We do table creation. We identify foreign key, primary key, blah blah blah. If you want to change anything, you have to change the table structure, which is like a nightmare. But with the graph database, right, it's schema light, right? It's very, very easy to dump anything into the graph database. So apparently, the graph for organizing or storing the knowledge has its own advantage. Then retrieval, that's you. So if you look end-to-end, right, from the source, and whether your source is from the user question or from the corpus of the documents, or maybe you have a graph database already, right? The first step is just identify your data source, then decide how exactly your data source needs to be put into some certain format of knowledge organization. So if you ask when should we use a GraphRAG or not use GraphRAG, probably the first question is, do you have a graph already, right? And do you have a relational data source already? If your goal is to make the normal people to access your data, to analyze your data easier, you probably don't need GraphRAG or Graph yet. You might just use a language model, fine-tune it to do something like a text to SQL, right? Train your model to recognize a question, translate it into SQL by providing it with a database schema. That might just work very well. So your first question, what you might want to ask yourself is, do we really need a graph? Do we have a graph? Or do we really need a graph, right? Then if you have a graph, right, then the different patterns you can use the graph for, right, in this scenario, in this architecture. For example, we can break down the sentences into entities, relationships, or similar entities, similar relationships. We can merge them, link them, break them, to build this knowledge graph, connect the knowledge graph. Who lives where, born in which year, won which prize, at what place or what age, in which area, which research area, so on and so forth. That's a graph. Interesting, there's a second pattern which just use a graph as the indexing layer. So basically we can let the large language model to generate summary of the document, for example, or part of the document. And to do the general embeddings. Through the embeddings, we can calculate how similar two paragraphs are like each other. Then link documents, and to do this just use graph as like an indexing layer rather than storing the actual knowledge. That's another pattern, which can also work very well if your primary use case is to do better search, right? Then once the knowledge is somewhere in the graph, right, then the next step is retrieval. During the retrieval process, multi-hop question, pretty simple, pretty straightforward. From the question, firstly, identify which entity, which person, name, location is mentioned, and then locate that entity in the graph. From there to see what are the related and other entities and what relationships there are in the knowledge graph, right? Then you just keep going until you get to the point you think, oh, all the large language model thinks the answer is there, right? That's the traversal path. Or you can do the search using the index. The graph provides a second index, and combine with the fuzzy text match, this kind of index, do some kind of fusion, whatever, right? Some kind of manipulation just to do the re-ranking to decide which chunk or which document is probably the most relevant, and to provide and feed that those chunks into the language model. And then once the retrieval process is done, we should have a list of contents, right, somewhere. Then we just manipulate those, we just embed those contents into the prompt, right? Give it to the large language model. Or what's more interesting is I saw a paper recently, you can actually provide a graph to the large language model. And actually some of the models with some special integration, you can actually let the model understand the graph structure. Or you can simply put all the text from the node, from the relationship, from the node, concatenate all the text as a long piece of text, and give the text to the language model. It can also recognize it and do very effective generation based on the context, based on the text. And by doing that, we actually kind of limit what kind of the content you want a model to generate from. Okay, it's pretty quick. So it's a lot of things going on at the moment, and I would think that some of the future directions to further enhance the usability and the customer experiences of GraphRAG would be, for example, multimodal RAG to combine text, image, video, and so because as I mentioned, the graph itself, the knowledge graph itself, you can also put something like the picture, the summary of the picture, or the embedding of the picture as a property, as a node, right, on the graph. Or enhance user engagement. That's also one of the lessons learned from my previous project, which was during the RAG project, right, the end user didn't have much idea what exactly the IT team was doing, right? In the past, what we usually do a project is like, let's collect the requirement first, right? Requirements. From the requirements, we design like a feature points. We do the breakdown, like a work breakdown structure to do like a design, then break down into build items, so on and so forth. So we do like whatever is agile or waterfall, just a matter of the size of the cycle deliverables. But now with the RAG project, right, if you ask your end user, they might just give you some very simple, because they can't see what exactly you are doing or understand what exactly you are trying to do. So the challenge was like the IT put a lot of efforts, try to dump everything into the knowledge graph. Then end users had a try, and said, it doesn't work. It looks strange, right? Then what are you gonna do? So the end user engagement is very important, but also I would think personally, I think the life cycle of the RAG project will probably look very different from a traditional, even like agile. It's agile, right? Agile delivery type of project, because it will be much smaller iteration and a much more fast feature change, I would think. Yeah. Because coding nowadays is no longer the challenge, right? You all know. Then beyond the search, the use case is also very important. What exactly you're trying, the business value of the AI. It's always everybody is worrying about, I don't know whether you are worrying about the AI bubble. Yeah, AI bubble. Yeah, NVIDIA now over like 5 trillion, is it? The market value of 5 trillion. 5 trillion. Unbelievable. Yeah. There's a bubble there, of course, but that's not our concern. So the key is to actually drive the business value. What's the business valuation? How value proposition, right? How you can actually make the AI, the RAG, will actually produce the value, right, for the business. Then standardization. I think I've seen some of the standardized evaluation frameworks came out recently. So this actually can provide much better guidance. Like for example, how can we make sure how aligned the solution is with the policy, regulations, policies, so on and so forth, right? We all kind of heard a lot of strange news about how AI didn't work at our enterprise, caused the trouble for the company, damaged the customer experiences, relationships, right? So on and so forth. Okay, the final. Yeah, that's apparent. It worked, but still a long way to go, right? And I also want to emphasize the RAG is actually end-to-end challenge. And maybe I saw somebody said like 1% of AI, 99% of the data. So we still have a job, so don't worry. It won't replace any of us. The data quality, the relevance of the retrieval, the structure, how we store data, how we model data, graph, relational tables still matter a lot, right? Yeah. And finally, I want to also share maybe 3 more minutes about how I actually did this project. It was actually done while I was on holiday, right? I just pulled out using ARXIV's API to pull out, here's the search words, here's the keywords, just give me all of the links, the titles, the abstract of the papers, right? I got that many. Then I put those into a large language model, label each paper by its net subject and abstract into those categories, like whether it's about retrieval, whether it's about generation, or whatever end-to-end application, so on and so forth. So I did almost like halfly automated, right, within a few days. In the past, going through that many papers by a single person is kind of impossible, right? But with AI, with GenAI, at least to this, it works very well. And you can actually check the GitHub link, which has all of the Python code, the prompt, and also the results, like the list of papers, the list of the RAG systems, and what they actually do from there. Okay, probably just roughly on time, right? Okay, and feel free to check my Medium, and I think we still have time for some questions.